So I'm talking about mixed realities and how you could achieve it, that your browser has been able to show the mixed reality creations you have and what you can do and what you could expect in the future, what the browser is also able to. So we're not going into native development. It's everything web development based. So just about me. My name is Carsten Sandtner. I'm technical director at MediaMan in Mainz in Germany, and I'm responsible for the complete IT, for the operational, for the developers, for the QA, for the system administration, and I'm a web developer since 1998, so my background is web development. I've seen many browser wars, and I'm just a believer of the open web and open standards, and yeah. If you want to contact me, Kazarock at Twitter, or just take a look at my website, you may find my mail address and other ways to contact me. I'm also organizer and co-organizer of the Rhein-Main.js. It's a user group, JavaScript-based, and we have meetups more or less regularly. Last 2 years, we were a bit less regularly, and I'm a Mozilla tech speaker, so it's a group of volunteers who are able or are allowed to speak on behalf of Mozilla, and they are supporting us with technical background information and so on. And this is a talk about something Mozilla is pushing. It's the mixed reality or the augmented reality, virtual reality in your browser and what you are able to do. Before I'm starting, let's do some time travel. Let's get back into history where virtual reality and augmented reality nearly came from. Maybe there are some other things in the military area where they were faster, where they made other things. But it started at 1993 with the 1939 with the Viewmaster. It was a device where you can see stereoscopic photos, and it showed you a nearly 3D scene using those pictures which were made for the left eye, for the right eye, and you could step through the disk, and every photo of the other side are one of these pictures, and you have 3D view. You see, head-mounted displays nowadays are still the same. So you're near your eyes, you've got a display which shows you a scene, a game, something like that, in a stereoscopic view. Later on, there were game developers who take care and said, oh, that could be great. It was Nintendo. They said, OK, let's try Virtual Boy. Virtual Boy was available for the masses, so you could buy it. There were around 25 games, but the problem was those LED display was terrible for your eyes. You got a headache. The whole hardware was heavy as shit. It was not usable, and the technology wasn't so far in this time. So they stopped to produce it, but it was the same technique behind the head-mounted displays nowadays. 2013, there was a disruption in virtual reality. A company called Oculus had the Kickstarter, and they got founded, and the Oculus Rift was born. It was the first head-mounted display somebody could afford, and which was capable to create immersive VR experiences for people on the computer. Many others followed. 2014, the cardboard from Google came, so they decided to put a mobile phone into some head-mounted display and use the mobile phone as the display, and using the positional trackers in the phone everybody has. And yeah, many others just are using the same technologies behind this. But Oculus Rift made it available for the masses first time, from my point of view. So VR got traction. It got people who wanted to using it. Then Project Headsight. This was a project 1961 where it was some kind of head-mounted display for virtual reality. As you can see, there is that's not good. This is a cube with a laser protection in the room. So the man who's using this display could see this cube, and it was at the time the first augmented reality. It was used for the military purpose, for to train pilots It was extremely heavy because the whole thing over his head was a big, aperture where the whole cables and so on and the big mainframe was being used, and it wasn't consumer ready. This one is consumer ready. It's affordable. Everybody could buy it, and you could use it, and it's real augmented reality. So you have a display for your eyes, and you see your reality, and you could augment it something like that into this reality. And the HoloLens is able to detect surfaces or things in the room to take care of it, that the virtual reality, the virtual part of this of your scene is not colliding with it. 2017, there was something, I call the AR revolution, when Apple introduced the AR kit as a SDK, and they brought AR, markerless, tracker-based AR, on everybody's iPhone. No, not everybody, maybe those who have an iPhone 5 or something like that were not able to see it, but you have a really good user base where you could create augmented reality. So they are detecting surfaces, and with ARKit 1.5, they could detect walls too. So this was the missing part. Now you are able to detect everything in your room you need for a great AR experience. And Google, of course, followed with the AR Core, which has basically the same techniques, using the hardware we've got now in our pocket with AI support. And so you could create great reality, virtual, augmented realities. I'm talking about mixed realities and XR. Let's see what this, but let's go into virtual reality a bit deeper. We have a mobile-based setup, I've told. So you have a phone into your cardboard, and you have it right before your eyes with some lenses to have the screens not blurred. And you are able to have okay enough virtual reality experience. There is a computer-based setup where you have a head tracker, a head-mounted display, and some other positional trackers for the room, maybe for the HTC Vive. And the signals were transferred by USB or HDMI, and it's a bit more expensive because you need a computer who's capable to render all these scenes for at least 2 displays right before your eyes, and maybe if you want to control or you want to see what the people are seeing when you're going outside, you could see it. So you have to power 3 displays with this 3D scene, and but it's affordable. You can buy it. And the problem is you have a lot of cables, and there's something like this virtual reality nowadays. It's getting better. When you look at Oculus Go, it's just a cableless, computerless, powered by the phone, HMD. We are using sensors, so it's still the computer-based setup. We're using sensors to track your device in the room. You track the position of your device in the room. And you have a field of view for virtual reality. If you want to create a good virtual reality nowadays, you need an angle between 50, 60 degrees. Normally, we have a field of view about 180 degrees. At the 2018 F8 by Facebook, Oculus announced their half dome, where they have an eye tracker and they have movable displays. So the problem is when your eyes are moving, your brain is getting out of sync, some kind of that. You're getting sick, you're getting motion sickness and so on, because when you see something, when I look in the crowd, I could look there without moving my head. And you don't want it if you are creating a virtual reality. Now with Half Dome, we will see maybe it's a game changer again by Oculus using the eye tracker and the movable displays. And at least to have a good virtual reality experience, you need 2 cameras, virtual cameras, to create a stereoscopic image. That's all. You have an image for your right and your left eye. So these are the basic concepts of virtual reality, very basic concepts. And I would like to show you the next part. What is web VR? Web VR is described as browser API that enables WebGL rendering to headsets to access VR sensors. So what does this mean? Currently, we are on the version 1.1 of Web VR. They've renamed some APIs from 1.0 to 1.1. So currently, we have these APIs. So it's something to get your displays. They are attached on your computer, or the display could be a phone in your headset, in your cardboard, for example. You can get eye parameters, the positioning. The position sensor gives you the current positioning from the device and from near, far, and so on. Layer in a display capabilities. It's getting important because you need to detect what is my display able to show. We get into it when we are talking about web XR or web mixed realities. If I want to get the device from the computer, so now you have to get the VR displays. It returns a promise. The promise passes the displays when found. And if you have one display in your area, you have at least one display found. So you could assign it to your display and you could start your drawing. That's all. So what's in this drawing? When you want to draw, you get a request animation frame from your display and the draw scene. And now you get from your display the frame data. So this populates the frame data with the current data. The hardware is telling the computer, here I am, this is my positioning. And you could get the positioning sensor and your current frame position, the position for the current frame. The frame is about every 1/60th second should be repaint, 60 frames per second. And you have to deal with it, your orientation, your position, and there would happen a lot of WebGL stuff you need to handle. I won't get into this WebGL stuff. Basically, it's matrix transformations and so on. But there's more you have to deal with when you want to create a web VR experience. So you have to import a polyfill. You set up the lights, initialize the scene, the cameras, the VR effect has to be installed. You deal with meta text and mobile, and you have to figure out responsiveness. You don't know what display is showing my VR experience at the moment. You have to deal with it. It's your task. So I'm a web developer. I'm coming from web development. I don't want to deal with these matrix transformations in deep. I don't want to create a stereoscopic rendering. And there is a project Mozilla initiated. Now it's community-driven called A-Frame, which takes care of everything I have to do. This means use markup to create VR experience that are working across all devices. So if you have an Oculus Rift attached on your computer, you could use the Oculus Rift. You can use the controllers. You could use the whole display, and A-Frame will take care of it. Below, under A-Frame is the 3JS as the WebGL framework. So if you are able to create things in 3JS, you won't be stopped. So you could get every element and you could manipulate it as you want. So what does A-Frame do? A-Frame uses something like web components to create new component tags, which describes a scene. It's declarative. So you're describing declarative your VR scene. You have a scene. In your scene, you have a box with an ID. The color width, height, 1 means 1 meter in 3D units. That one, and the position is 111, means 1x, 1y, 1z, so something like that. And rotation is 0, scale 111. I don't want to scale, it's just the scaling, the 111. And I have a skybox, which means only color is gray. So the skybox is the surrounding box of your scene, and you could also create a skybox with a 360 panoramic photo. So it will give you a skybox with a real sky or the 360 image. And what you also can do is you can nest some things. You can say, okay, I have a box, and in my box I have an animation with a rotation. So this still everything's declarative. You don't have to program any JavaScript, and you're getting this. It's a box which is rotating, and if you are activating this button and you have a display, it will take care for the 3D rendering and the rendering of the stereoscopic image and the positioning trackers and so on. But this would also work on your browser. So you could, using a so-called magic window, where you could navigate with WASD or with your mouse to see the scene. So it's already progressive. You don't have to take care of the other displays. And it has an entity component system. You have an entity with a geometry. This all, if you know 3JS, you will think it's, oh, I know what you are talking about. These are all parameters 3JS is using. So they are just wrapping up them into a web component. So you can compose it using positioning, rotation, scaling. You can give an animation in your entity, rotation, loop true, and so on, and movement pattern, so it would move right to left. So I come to the end of WebVR because my talk is about WebMR or XR. So awesome use cases for WebVR, just to be complete. This is an awesome use case created with A-Frame, Syria, 360 Syria. At this year's South by Southwest, I've seen the keynote from Noni de la Peña, and she's describing how they are using VR for immersive journalism. And I think this is a great example how you could use web VR. So you should not aim for a sophisticated game or something like that. You should aim for short and immersive journalism or something to explain, like manuals for cars or something like that. This is a really good example. You could use it without any VR equipment, but if you have a cardboard and you have an iPhone or an Android, you could use it with the cardboard, and it's very impressive and immersive to see the reality of war. Another great example is also created with A-Frame is the A-Painter. So you could paint with the controllers, which are detected by the hardware, which is attached on your computer, and you could use it in your browser, and you could paint 3D pictures. There's also a demo by Google where they did that, and it's also possible in browsers. And last but not least, Google partnered with Pepsi, and they created a cool page where they're traveling back in time, and you could experience how Pepsi evolved and what Pepsi looked like later. So it's plain WebVR. There's no A-Frame. This is plain programming, JavaScript and WebGL magic. And if you don't want to use any browser techniques to create your VR scene, but you want to target a browser, there's also a plugin for Unity, which is called WebVR Assets, where you could export your whole scene, and you could use it using WebAssembly and all those new techniques to get performant web applications, and you can use it out of the box of your Unity. Maybe you have to tweak something, so the code once runs everywhere isn't true. Of course, it wasn't true ever. And okay, that's for VR. Let's go into mixed reality. So before I'm going into mixed reality, I want to define what is mixed reality. So we have two ends of reality. We have the reality, the real reality, and we have the virtual reality. In between the reality and the virtual reality, we have the augmented reality. So we are augmenting something. We are putting something into your scene you see in the real scene. And in between those both. We have the mixed reality. Means you are creating something in the scene, and it is using everything the scene could provide. There's an example by HoloLens where they have Lemmings, where you can play in your living room Lemmings. Or Magic Leap, maybe they're coming soon, is working on AR glasses, and the only thing which is real in this room is the table, the rest is augmented. So this is where it will go. There's a lot of confusion about mixed reality, augmented reality, virtual reality. So many vendors of browsers decided, let's call it whatever you want, reality XR. So it's something between these. So as you see, there isn't a clear cut between VR, AR, or MR now. Let's get into some types of AR. There are 3 types, at least. It's the marker-based AR. I remember 10 years ago, there was a hype when you had a web page, there was a Java or Flash plugin powered application which used your webcam, and you could hold your marker into the camera, and there was rendered some 3D on this marker. This is marker-based AR. It never got this traction it may had because the devices were too expensive. Nobody wanted to use this laptop to use the marker. Now we have the iPads and so on, and it's working better. And you could see a real room if you want to, and it's using this marker to get the position of the room on your page. That's it. And there's markerless AR. When I got my first smartphone, it was an Android phone, because it was the only reason why I chose Android. There was an app called Wikitude, which was able to show your point of interest using your GPS position and some magnetometer, so the compass, and so it could show you, hey, there is a good pizza, Times Square, and so on. It was really impressive, but it never got the traction it may had. I think it was a good idea, but it wasn't available on an iPhone, on iOS, long times, and so it got forgotten. Wikitude is still operating and has a lot of great APIs. Maybe you keep it in mind. You could take a look if you're a native developer. And it's tracking-based AR. That's the AR, I think, which makes AR a game changer now, because we have your, starting with the HoloLens, you have this tracking, but now with ARKit and ARCore, you have these displays in your pocket, and they are capable to show those AR experiences. And we have the camera, we have the processors, and we have the chips which are only used for the AI operations inside it to detect the floor or the wall. And with ARKit 1.5, you are also able to detect images. So you could detect, in the museums, you can detect a picture, and you can augment some informations, and it's out of the box, and you could give it a trained model of image detection, so you could detect some rims of your car and just change it. So this is really a game changer, and this is getting really great, I think. So this is AR at all. But what is WebXR? So the browser vendors jumped on the train, and they thought, it would be cool to support AR too. And they decided to name it WebXR because they said, okay, we have something between, and we will get new APIs to create these experiences. So the WebVR 2 API won't get into the new standard. It will named WebXR Device API. So the browsers won't make any difference between a 3D display, like a head-mounted display, Oculus or a Rift or something like that, and a phone which is used to create an augmented reality experience. It has some drawbacks. It's not backward compatible. So if you are creating now web VR experiences, they won't work with WebXR. It's not focused on AR. It's just focused on detecting the hardware attached on a device or what's in your hand. And when they want to get into AR, they are focusing on the the tracking-based AR, like ARKit or AR Core do, because there is hope that the browsers will will publish the APIs to the Safari and to the Chrome, so you could use them with the JavaScript API you have to create. So if you want to get an XR display, you just request your device, and if your device is found, you have to do something with it. The API is in flux. It is not really stable. You couldn't use it real. That's just a recommendation. And the W3C has a good blog post where they describe where they see the immersive web and why they are doing this change to the APIs. But if you want to play with it and you want to see what it may be capable, there's also an A-frame XR fork, which is being found on GitHub. You could see the whole implementation. You could help to develop it. And what they do is, it's really simple. They define an attribute to your entity, which says, OK, this entity is for AR. For VR, I don't want it, and the magic window, I don't want it. Maybe you have any skybox. For AR, you don't want to see the skybox. So you can say, OK, no, this entity, I don't want it to see it when I'm AR mode. Which means you get renderings like this. So you could exclude something of the scene when you are on the desktop. Or you could include it when you are in the VR mode of your phone. And this is just the beginning. It's, the API is being evolved, it's being developed, and it's not ready. They're in flux, and they're changing constantly. So be sure if you are creating something, you have to recreate it maybe 2 or 3 months later. I did a VR talk, web VR talk last year, end of last year, and this year I had to recreate all my examples because they changed the WebVR 1.0 to 1.1 APIs and they won't work anymore. So it's just an experimental status, but you could use it with browsers you have to download on your phone. So there is the WebXR browser for iOS, there's ARKit on web for iOS and AR Core on I think it's AR Core on web for Google. You could search in the app stores and you get this browser and you could play with these APIs. This is something, Leap Motion. It's a device which is tracking your hands. And this is something we could expect because Leap Motion has also APIs for JavaScript. So you need the browsers, the drivers. But it would be possible to create, and I think it's I think it's great what's coming, and let's see if the browser will get it. But you may ask what are the advantages of WebXR? Is the web the right platform for graphic and for VR, AR, XR? Well, they are progressive. That's a great advantage. You have to support tons of devices, and you could support it with one code base. Of course, you are not able to create high-fidelity experiences, but you can create something on your company website which is being viewable on the desktop browser, on the mobile browser, and even augmented or in a VR manner. So they are progressive. With progressive web apps, you are able to install them offline on your iPhone, on your Google Chrome, on your Android, or on your desktop browser. So you don't have to go through shops, app stores, something like that. This leads to another big advantage. You have no gatekeepers. At the beginning of the VR hype, there were games which could be playable on Oculus Rift, but the same game, using the same techniques Oculus Rift is using, were not allowed to run with an HTC Vive. So you have these gatekeepers. So you are creating something open, like every web page is, and you could provide it for everyone. Nobody has to buy a hardware from some vendor. It's instant, so you don't need to install them. You don't need to update your Steam client before you can install your WebVR experience. And they are connected. If you want to share some experience with a colleague or with friends, you just send them the link to the web page, and they open it. They could install it using Progressive Web or Service Workers, and they are able to see what you've created. You can use it in a marketing campaign for a bigger company or whatever. And the biggest advantage is it's open. It's based on open standards developed by every browser vendor and community-driven, and W3C is involved. And there are no secrets. You could work on this, and it's what the web, what's making the web this what we are loving. We have open standards. We are creating something. Okay, we have to support some browsers, but it's getting better. When I think back to 1998 with Netscape and Internet Explorer, I don't think we have these times anymore, and we shouldn't have these times any longer. And with WebXR, you are able to use open standards to create your experience. And you are not able to use open standard when you're creating an app for an HTC Vive or an Oculus Rift or for Windows and then PlayStation. These are closed systems, and the web is open. This is the biggest advantage. And at least some links to everything I've shown. If you want to get into the immersive web from W3C, this is a good page. You can work on this. You can contribute. You can pull requests. And if you want to see examples, what you get, there are also a sample page, and the A-Frame XR page is also a good stop to see what is possible. So I recommend install one of those WebXR browsers on your iPhone or on your Android device, and just try it, and you will see there's a lot more what a web browser is capable to do if they have access to the hardware, as you could expect. And that's all. I would like to thank you. And if there are any questions, I'm open for it. Wait, I've learned I have to take this one.
When do you expect the standards become stable? How many
Okay,
years?
That's a good question. The problem is, as you've seen, the WebVR standard evolved. Yeah, it changed the APIs really often, and I don't think it will be available until 1 or 2 years. So, I say in 1 year we have a standard, but not every browser vendor has implemented everything. So the problem at iOS is the Safari must implement those APIs to get the surface detection. When you're looking at service workers and progressive web apps, Safari was the last one joined this train, and now they have also service workers. We are talking about service workers about 1.5 years, I think, and they never wanted it, but now they got it. So I expect we will have this problem that the one vendor of the closed platform will not update their APIs or browsers. Other question?
Hi. Are there plans to get surface area detection for like tables and walls and stuff natively to the browser as well, or just through plugins? And
The mentioned browsers, the WebXR browser from Mozilla you could install on your iPhone, or the AR Core on Web browser are exposing those APIs to detect the surfaces. And it is possible. And as said before, the gatekeepers at this point it is Android, it's Google, and it is iOS, Apple. They have to implement the standard which is being defined, and it is possible. It has been shown in those browsers. You can see they are working. I've got it on my phone. I can demonstrate it later if you want to have the whole API ARKit has for detecting and light estimation and detecting surfaces is already possible in the browser if the vendor would implement it. That's the problem in the moment. So the standard has those APIs. Yeah, they will be standard. Yeah, they should. They should. They have to. Okay. Some more questions? No? So, thank you.